Okay. Thank you for your patience. And first of all, welcome everyone. Uh, Good afternoon and a very warm welcome to today's webinar, Exploring Research Field for Efficient Steel Design. Uh, I'm Ashwin Nagar from Acero Consulting Engineers, and we are the official channel partners of the Nimishek Group. It's great to see you all joining in. Today, we'll take a deep dive into the most versatile structural analysis tools used worldwide. Coming to what we'll cover today, we'll start with a short introduction to RISA 3D and its core capabilities. We will have a detailed software showcase. We'll go through some real life case studies on RISA 3Ds. And finally, we'll have a look at RISA portals. And in the end, we'll have some Q&A where we'll discuss some any questions that you have after that. Uh, Before we begin, I'd like to introduce you to today's presenter, Mr. Kirti Chandra Joshi. He's a structural engineer at Acero. Kirti holds MTech in structures from Delhi Technological University, and he also has multiple certificates by RISA. He has hands-on experience across RISA 3D, Adapt, Bluebeam, IDEA, Statica, and many more softwares. He'll be taking you through the detailed technical walkthrough in just a bit. Before we dive into the product, a quick introduction about Acero and who we are at Acero Consulting Engineers. So we have worked with over 300 clients, deliver more than 30 products, and supported projects across 20 plus locations. Our work is guided by our four core values, which is putting customers first, providing reliable delivery and ongoing support, helping you maximize your product value from your software. And being an engineering driven organization led by graduates from top global universities, we focus mainly on support is so also share regular posters, webinars, sources to help you keep really get more out of your tools. Links to all of which you can find in our Q&A chat box. Coming to our products and solutions, here's what we offer under our Nimishek portfolio. Firstly, we have RISA 3D that we'll be covering today. In the RISA suite, we have RISA floor, connection, and foundation that is used for integrated modeling, connection, and foundation design. Uh, we have Adapt Builder and PTRC that's for reinforced concrete and post-tension concrete design. All plan is used for BIM-based design platform for architects and engineers. Bluebeam is a smart PDF collaboration tool used by EC professional. And not only so we have our other software portfolio as well. We have Autodesk, IDEA Static is used for connection and key connection design. We have Karamba, Shuriken, Adobe, and Aries. Trinity. So Aries is a good alternative to Autodesk. You are looking for a perpetual options. With that quick overview, let's dive into the RISA itself. I now like to hand over Kirti, who will take you through software through feature. So, Kirti, over to you. And thank you everyone once again.
So thank you, Ashwin. And am I audible, right?
Yes, you are.
Yes. So hi, good afternoon, everyone. And so for anyone like who is new to RISA 3D, I will start with a short introduction. So RISA 3D is a powerful 3D analysis and the design software from the Nimishek Group, which is used worldwide and in India as well. And it supports the multi-material, like you can model and design the steel frame, either hot rolled or the cold frame steels, and even the concrete member, timber structure, masonry, and the aluminum member all in the one place. And it also handles the linear and non-linear seismics and the wind load analysis. And it also supports the multiple design codes, including the Indian standard, like the AISC and the Eurocode. For example, like if you are designing the industrial shed or a steel building, you can run the same model for both the IS code and the AISC. And you can, either manually create your load combinations, or you can let the RISA to generate them based on the code requirement. And also RISA is used by the large number of the firms worldwide, and due to its flexibility and accuracy, you can see on the screen below, like this, it supports the different project types like the industrial structure, commercial structure, metal buildings, and the residential structure. So now in the slide, you can see why do engineers prefer RISA? Like because it's helps in the model creation in the easy way. Like everything is the task oriented and easy to modify as well. And the next is like it connects, easily with the other RISA tools. Like if you're working with the RISA connection and the foundation, so you can easily move from the structure to connection to the foundation. And the third is the reporting features, like the reports are clear, like you get the detailed numerical and the graphical result, and also the step-by-step design check values, which is useful for the design reviews and the client documentation part as well. The other points I mentioned is about the usability, like it is made by the engineers and for the engineers, which makes it technically sound. So also it has a cloud-based licensing, like you can log in from any system, so that multiple team members can use the software, and you don't have to worry about the device restriction. So moving to the next slide. So here is the integration part, like integration of the RISA 3D. Like you can integrate RISA with the other tools like the Autodesk or the Revit or the Tekla, or there is a software called STS2 and the ArchiCAD and the Excel. Like all the integration you can see on the screen is achieved through the link like which comes with the RISA 3D. For example, engineers can work with the architect by transfer the models from Revit using the RISA Revit integration, and also by using the Tekla structure integration. As you can see on the screen, anyone can easily transfer the geometry or the member in the design parameters to the Tekla structure that can be used by the detailers and the fabricators. And you can also link like the architectural models creator, like if you create in the Graphisoft ArchiCAD with some structural engineers model in the RISA using the RISA ArchiCAD link. Also, you can link the RISA with the other tools like the RISA sections, RISA connections, and the RISA foundations. That helps you create a full design scene within the RISA 3D. I mean, like you can analyze the superstructure in the RISA 3D and push the foundation load directly into the RISA foundation, and can carry out all the design connections in the RISA connections. And as you can see, the RISA sections allows you to create a custom shapes and sections for you to use directly it into the RISA 3D. So moving forward in the slide, you can see the types of the file RISA 3D support for both the import and the export. Like you can open an existing like the 2D files or the DXF files, the STAR files, or even the Autodesk Revit file, and the Tekla structure files, and the TNX tower file and the SAF file. Also in the right hand side, you can see the export options that RISA support, like you can export it into the DXF and into the area builder, which is for the concrete design, and the STF file format you can transfer, and you can transfer the model to the Revit back as well, and also to the STNF file. So this STNF is a file format that is used by the number of the steel CAD and the steel detailing. Also, like you can see the SCF file format, like it is an open exchange file format that allows the exchange of data between the structure analysis software, and it consists like the information such as the geometry, section force. Like it is an initiative from the Nemetschek group for the collaboration part. Moving forward, like you can see the interface here, RISA is a quite user-friendly interface, and you will also get customizable toolbars and menus that can help you to speed up your modeling process. I mean, you can adjust your toolbars and menus and the layouts according to your workflow. And it also has some pre-built like the modeling templates available within the RISA 3D that helps you to start the modeling quickly. For example, let's say like you are designing the three bay portal frames or the standard truss, like RISA let you to generate that geometry with its template. For example, like there are some templates for the circular template that may be great for some kind of aircraft hangar, or the grid templates that may be for the industrial or the like commercial buildings. And also the cylindrical template is there that work well with the chimney kind of the structure. And also the dome kind of template is available there for creating the dome, and the water tank template for creating the rectangular water tank. So we'll take a look at the RISA interface video here. Like we'll show you the interface of the RISA 3D and the quick feature. Like we'll start with the modeling. Like you can see, you can create a new project, and you can open an existing project file once you open the RISA 3D. And in the below tab, you can see if you're new to the RISA, you can get the video tutorials and guides to let you explore to the RISA 3D. And once you open, you can the project information tab is open, where you can give your details. Like I'm writing my company name here, Acero Consulting Engineers, and the designer, the name which you can put there. And in the right hand side, you can see at the top, there are options to save a file, to open a file, to print of files, for like undo and redo, and to take a screenshot, and the general information about the research CD. And in the file, I'm going to open my new model file here. So I have opened my new model file through the file options, and for that I'm giving it a model name, like a hybrid structure, because it consists of the steel as well as the timber, as well as the like the wall is there, like the concrete wall is there and the masonry wall is there. So I'm just giving it the project information details. Like this is a quite a kind of interface, and if you want to change the unit, you can just select the unit tab at the left hand side, where and you can change the unit. And in the setting tab, you will get a general if you want to apply some settings to your model, like if you want to change your code, or if you want to change your axis, the basic information can be found through the setting tab, that you can use it before starting any modeling. Like the code setup, you can easily done from the codes tab within the model setting, and you can set up some setting for the concrete and the rebar, the minimum percentage of the steel, like something like that. And in the top bar, you will get all the features, like the modeling feature from member, plates, wall, and how to apply the loads, the of load, and how to create the load case and combinations. And the important is you can see the select by property toolbar. This allows you to select the members or any part of the structure from your model just in the one click. For example, I'm going to select a beamed kind of the structure from my model. So I'm just using, rather than selecting it from the model one by one, I'm just using this feature. If you want to select all, you can just use this like the toolbars available at the left hand side of the screen. And if you want to view it in the dim log, or if you just want to see this member, you can just use this dim log features, and you can easily use the copy features available in the modify option, just to copy your member in some particular locations. So I'm just want to highlight some of the interface, and where you will get to see all kinds of the feature within the RISA 3D. For example, if you want to add a node within the member, you can just use the features available under the modify tab. Like if you want to split a member, or if you want to add a member just without splitting it. And in the view tab under the model, this is this allows you to view your model in the render view. Like if you want to view renders, like how much percentage you want to see it in the render view, it will show you. Because like right now you cannot see the walls have been properly connected to the node, just because we have not set the render view to the 100%. So if you select it, you will just see you will get to see the full 100% render model here. By this way, you can just set up within the RISA 3D like how much of the transparency or how much of the render you want in a model. And in the this member icon tab, you will get to see all the information about the sections, shapes, materials regarding the members informations. And for the nodes, you can just use this node tab to display your node values. And under the drawing toolbars, if you want to display your grid, you can just click on these icons. And if you want to just hide, you can just can do that. And in the spreadsheet tab, you can get all the spreadsheet options to define a section sets or define a member materials and all the design rules. That is also available in the right hand side of the screen. And you will get to see all the seismic load generator, wind load generator features, and moving load feature within the advanced tab. And you can see all the sections are available for the AISC Indian. So you will get you can just select it for the different types of the material, like the hot roll, cold form, or the timber material. So through the sections tab under the advanced, you can just go through it. So all of the information can be found easily within this toolbar. So under the material tab, if you want to, simultaneously see the material tab and within the section set in the same page, you can just toggle the window in the one view so that you can work simultaneously on different kinds of the sections, material, and even the model. So if you want to display the load, you can just go on the model view setting and can open all the settings so that it will help you to show the loads based on the area load or the point load that has been applied in the model itself. So if you want to see the particular type of the load, you can just select this load. And for the wind load, it has been applied on the wall. So the wind load had been shown. So if you click on that load values, you can just, change, will get to know the more information about it, like the wind load has been applied, then the tapered load has been applied. So it has been applied over the entire wall. So this is the general setting, like where you can apply, where you can see your loads, how you can apply a load, how you can change your units within the RISA 3D interface. This is, and even if you want to change the unit, just you can select the unit tab to change your units. It will automatically change the unit from KSF to the MPA right now, KPA right now. So like the imperial to the metric system, it has been changed. So the next topic we are going to focus today is on the single angle and how these, hot rolled steel sections are considered in the RISA 3D. So if I talk like the single angle is a bending element in the RISA 3D because they are doubly asymmetric. So with this behavior, like we do some different approach. So when we consider the bending about our X and the Y axis, like basically we so how do this differ from the other shapes from the analysis? We considered basically the principal and the geometric axis here. So by default, RISA 3D will automatically assume that the full bracing is not present and that the bending and the buckling will occur about the principal axis. And this is a conservative assumption actually. So in the image on the right hand side, our geometric axis is the YZ, and this is going to be parallel to our horizontal and the vertical leg. And however, if your single angle is unbraced, that then we are going to see the scenario where the principal axis, which is going to control like the Y prime axis, and the Z prime axis as shown in the image is going to be the strong, like the Y prime axis is going to be the strong axis for the principal behavior, and Z prime axis will be the like the y prime will be the weak axis and the z prime will be the strong axis for the principal behavior. So RISA will calculate this angle alpha as shown in the image and going to transpose the moment like m prime, mz prime and the my prime. So I mean to say that when a single angle is unbraced, RISA will calculate the moment mz prime and my prime with the angle alpha. So like how it actually affect the code result is, so basically a principal like the axis and the longer unbraced length like result in a smaller axial in the bending capacity. So we'll also take a look at a single angle behavior in the model video I've created in the next slide. So I have opened my kind of the pipe rack structure in the model. So I'm just giving it a name single angle behavior, and just I'm writing my company name and the designer name here. So before starting any kind of the model, you can just give the project information. And this model is just for the demonstration purpose. So you can see the model in the wireframe, color code, or the render view. So I have my like the white flange, hot roll steel section, and some angle sections here. And if I want to work on the particular like the sections, I can just I have already saved in the different saved selections view. I will just open that in a bit. And you can see all the sections that have been assigned to this model. Now I can just see the view in the different view, like the earlier was the isometric view. And if I want to see it in the YZ view, you can definitely see that. You can see the information about the material and sections to the left hand side as well. Right now, I am going to open the shaped selection state that have been applied for the single angle. So I've already applied a single giving it a name single angle, and I'm just going to retrieve it from the whole model. So I'm just going to focus only on this part so that I've only saved this part from the model. So how this work, we can just see that, unlike how you can save it in a different view. For example, if you have the whole model, you can just select any of the member or any of the member, like you want to save it in a particular view. And then you can just select it, then just use the features of the saved selection state from the left hand side here. And you can just use the saved selection state, and you can just give it a name so that it will save this particular view from the model only. So if you click on the state 6, which we have created, now it will show you that particular part only. But right now we'll focus on the angle, a single angle behavior. So we have just select this part, and we have already retrieved it. And we can see it in the render view as well. So I have my angle sections here, and all the information can be seen on the property toolbar at the left, and all the section sets data can be available from the this we have already opened here. So if you want to see in the geometric and the section property data, you can definitely see it. And in the design parameters, like we have right now, it has the single wingle is unbraced. So you can definitely go through the unbraced lens if through the RISA 3D help file. So YL comp and YL bottom are the, it will, brace your beam types behavior in the top and the bottom flange. So you will get to know more details about this, like this, how the single angle result through the help file of the RISA theory if you want to explore. So if YLCOM bottom and YLCOM bottom have been set to 0, that it will be considered as the full brace length. Like we have not provided any unbraced length, it will consider as a full brace length. So we are going to write a value of YLCOM top and YLCOM bottom at the 0 in a scenario that will assume the full bracing. Right now, we have not applied any of the bracing. Then we are going to see the results for these two models. So we have opened, we can simultaneously open the results for these two models, and within the sections, now you can see the pass-fail ratio as well. And in the flexural buckling options, when you, go in more details about this particular check, you can see the we have not, it uses the geometric axis right now here. So if it, sorry, it has used the principal axis because uh, we have considered not considered any of the bracing. That way it has considered the geometric bracing, because right now we are able to give the full bracing here. That's why we have provided the value of 0. Now we'll compare the results in such a case, like how it will going to calculate my moment. So this one is the condition where the bracing has been provided, and this one is the condition where bracing is not been provided. So it will behave as a geometric axis, and this will behave as the principal axis. So for the principal axis, we are going to get the moment. Different types of the moments values can be found here. So right hand side we are getting the geometric axis moment, and in the left hand side we are getting the moment as the m prime, which is the principal axis, and here we are just getting the moment not as the prime, because the angle alpha, it will calculate the transpose like we have seen in the previous slide. So for the same result, if we have provided the full bracing and not provided the bracing, that our moment value is going to change for the principal and the geometric axis as for the bracing condition we have provided. So we have just shown that values and taken out the code result values as well. So the next is we'll focus is on the torsion and like what checks are performed in the RISA 3D. Like the point I would like to highlight is like when there are the significant moments on a member like about its longitudinal axis, then the torsion is going to control, and this is shown in the image in the left hand side with this fixed end beam. And I will also highlight like what shapes are we checking for the torsion. Like we have the idea of an open shape versus the closed shape. And when it comes to the RISA 3D, it is subjected only to the open shapes, only for the torsion. So warping effect are considered only for the wide flange and the channels. So it is also more accurate, to consider the warping effect when calculating the member stiffness and the stress. But there is a way you can turn this effect. In the model setting tab, like in the model setting tab within the RISA 3D, you will see the checkbox consider the torsional warping as shown here in the slide as well, will display in the model as well. So RISA also calculate and list the torsional stress for the member of the structure, like including the warping stress and the shear stress, like the pure torsion and the warping are also included in the shear check within the result. And also it considered the warping normal stress are also added to the weak axis. And we'll also take a look at the torsional behavior in the model video in next slide. Let's see. So we have the same model. So I'm just giving it a different name here, like the torsional check. And in the setting tab, like I have mentioned, you can just see if you want to consider the torsional warping, you can just check the box here so that it will calculate all the torsional stresses. And in the unit set, definitely you can change all the units from imperial to the metric. So for this behavior, we are going to use the grid lines 4 and 5. We are going to see the torsional behavior in one of the beam member that is in the grid 4 and 5. So you can see there is a beam member and there is a kind of cantilever types of things, and we have applied the torsion value. It is like a quite significant value of torsion we have applied here, and this is going to create a warping effect in this beam. So we'll see the analysis for this beam member. So we have just run the analysis. And in the member torsion options display result, you will get to see all the values like the torsion values and the warping shear stress and the warping bending stress values. And if you want to sort it from the absolute maximum to the minimum, you can definitely do that. So by once you calculate the values, it will give you the detailed result for the torsion as well. So you can see the values here. But right now, our main focus is on this particular type of the beam, which we have created a high significant amount of the torsion. So we'll just display the deflected shape, but this deflected shape gives me the quite doesn't give me quite a clear image because of our whole model. So we'll just select this beam element only, and we'll lock other structure, and we'll focus only on the particular sections. So I'm going to just select this member only and I'm going to use the lock features available. I can just dim lock the other members. So right now I can just open my deflected shape. Right now we can see this clear image. The warping effect has been considered due to the torsions, and it has been full rotating. So if you want to see the reports for this member, you can just click on the report options and just click on the members. You will get to see the results. So when there is a torsion in our member, so our shear analysis is going to basically it will just affect mostly in the shear analysis. So right now our capacity and demand ratio have been here. The values can be displayed, and it has shown that it has applied loading of combined shear and torsion. And in the top side, you can also see the stress. Our shear stress in the y and x axis is quite not significant, but due to the torsion, it is significant. We can see these values in the detailed report as well. So you can also go on the RISA 3D help file just by clicking the F1. And you can just go on the member. Under that you will see the torsion, and you will get a detailed information about the torsion, how this can be considered in the RISA 3D. You can just browse it. So here is the same thing I have already highlighted. Like if you want to consider the torsional effect on, you can just click it. We do have some blocks available already in the RISA website. You can just explore it. So here is the question mark symbols available. You can just click on that, and it will take you to the help file directly as well. So another topic like we'll focus is on like the two tools that you can use when consider the eccentricity when modeling in the RISA 3D, that is going to be the rigid end and the analysis offset. So the first I would like to highlight is what is the center line analysis. So all the members will be framed like the center line to the center to center in this model. In the center line analysis means like everything is going to model node to node. For example, if you have any column or beam, you are actually framing in the center of the member. Or you can see in the truss example in the slide, like all of our waves are framing into the center of the chords. So typically center line modeling is sufficient, but there might be some case where this approach might not be we're going to take. So how do we account for a non-center line analysis in our member design? So for that, we can use the two tools like the rigid offset and the analysis offset for the non-center line analysis. Like rigid end offset as shown in the image in the slide. Basically, we create rigid zones at the end of our members as shown, and it is going to shorten our member and create a stiffer elements in your stiffness matrix. Like it will add additional stiffness when you solve the model. And the second is the analysis offset, like which is shown in the bottom image. This is going to create a rigid link in a model and offset a member from the center line. So we'll take a look at the rigid end and the analysis offset in the model video in the next slide. Let's see. So I have again my same model. So I'm just giving it a different name like the analysis offset. So right now I'm just using the shaped selection instead from this for this analysis offset model, and I can just change it in the YZ view, and we can display it in the form of the render view as well. Right now you can see it has not been full 100% render is not been applied, so I will just click on 100%, and I also want to see the transparency. Let's say I want to keep it at 50%. So right now you can see I have set my rendered 100% render model. So right now you can see it has been modeled center line right now, but we are going to create a rigid end offset here. You can also see which end is I and which end is J. So you can also see the I is the N121 and J is the N22. So you can just display the node. One approach is this, and other is you can just display the I and the J node as well. You can also do that so that you can display the I and the J end. For that, you can just go on the member icons and you can just display IJ end. So I is basically the red and J is basically the green end. So any approach you can take. So I'm just going to create apply some rigid end offset. So we can also check we have already applied some moment connections here. That has been denoted by this circle, like the pins have been created. Also, we are going to see these columns. The column depth is like the 12. So we are going to in the middle. So it is 6. So we are going to offset it by the 6 inch. So at the I end, we are going to write the 6 inch so that it will shift. It will shorten my member. Right now we are not able to see it, but once you go on the model view settings and in the wireframe, once you click on the rigid end offset, then you can see this link has been created here. So for similarly for the J end, you can just use this member reference member here, and it will automatically select the depth and will provide the offset. You don't need to write the depth in the form of number as well. So that is your approach. Like you can just give it a number, or you can just give the reference of the column as well. Basically, it will take the half depth. So you can just rotate your angle. So right now we have already created the we have already shortened the members. So we are just going to run the analysis. Right now you can see it is not model in the center line. Like we have provided some offset here, and for this also you can see some offset has been created here. So you can also see the Y shear force value, like if you click on it, the full length has been considered here, but here we have provided some offset, so it has been reduced to quite 18.9 because 12.1 is something, and we have a 1 point offset given of 0.6. So based on that, it is considered only that portion of the length. So we can also check this from the report as well. And in the member options from the data entry, you can just see which members we have provided the release edge and which members we have provided the offset. You can just see that. Just now we are just clearing it, and we are going to provide the analysis offset for this member. Right, for that we are going to see the local axis. So this is my Z axis. So I want to give some offsets to the Z axis, like we can just click on select any member, and we can just press the control button to select the multiple member. And for the analysis offset, we have now options here. So in the local Z axis, we are giving some offsets, say for example 0.5 5 pins, we are going to provide offset. We can just click on that. We have already provided the offset, but in the if we click on the render view, we are not going to see it's much difference. But if the other thing is if we click under, then we are going to shift it. So this way we can just visualize the offset has been created, or even it can be checked from the property toolbar. Now we are going to solve this model. So every time once you click the model, now you are getting the node reactions, but this can be set up. We have set the member deflections option right now, so we'll not get the node result, but we'll get the member deflection. This way you can also change what to show when you solve a model. Right now we are comparing the two sections. Right now, for example, if I'm interested in ZZ moment, so here the moment diagram is different because we have provided some offset and it has created some eccentricity here, and due to which the moment has been generated. So we have get some different diagram for the moment. So right now I come back to my view, and in the help file you can also go to the members, and you can just go to the analysis offset features just to see it. So the last topic we'll discuss today will be the workflow for designing the hot rolled steel structure. Like we'll go through the process of designing the hot rolled steel from starting from beginning to the end using some of the tools in the RISA 3D that will help us with the optimization. We'll look at creating the section set as the step one, and we'll assign the design list to each of the section set, and we'll also set some of the design rules for the member, and we'll perform the code check on our structure, and finally we'll look at the suggested design to complete the entire design of our structure. So we'll take a look at the model video in the next slide. So let's have a look. So I have taken some hot roll steel kind of the structure here. I have got some columns, I have got some girders, I have got some beams here. I have just modeled it. You can just see it in the render view and in the wireframe view or in the color coded view as well. You can display the material, you can display the sections by clicking on this member buttons options. You can see the section set for other section set. We have just seen the ENA, but we have the section set for braces only. If the materials the material assigned to the different set can be displayed through the material options available in the data entry option at the left hand side. Now for the load case, if you want to set a load case, you can just dock it below. If I want to display my loads, like the load shape I have already applied in the form of the area load, a distributed load, and it has applied to the member as well. For that, you can definitely change the unit like I mentioned earlier as well. And in the load combination, you can see the deflection load combinations here. I have just used as the load generator combinations using the AISC. You can just use the other load combination regions as well, like the Indian region is also available here, and the different codes are available. You can just select that as well. We have also the P delta analysis on. If you need to get more information about the P delta, you can just go through the help icons, and you can just have the P delta analysis information here. Like we have applied the point load and it is going to create a secondary moment. So we are going to consider that effect as well. So we are going to run the bash plus envelope. It will solve all of my combination and give the worst case scenario. So for the unity check right now, you can see as for the different types of the load case and the combination, you will get the unity check. Right now, it has been denoted by the color. So most of my beams members have been failing here. It is in the red. The utilization is above the 100%. So we can just use the program suggested features and we can display it by absolute maximum and minimum by sorting the values. Now in the left hand side, you can see the material takeoff values, like for the particular materials you are getting the weight that can be displayed. And in the suggested design tab, the important thing to notice here is for the different member, I have not created any of the sets. So all of my members have been given here, and for each of the shapes, there is a different shape for the member. And if you want to use the program suggested shape for that member, you can just use that. But later we'll create the section set, so that we'll create the section set for column, beams, and girders, so that all the members will not be displayed, only the section set will be displayed, and that will help me in the optimization. Right now, as you can see, only the braces have been assigned as the section set. We have just opened the section set options from the data entry tab, and we are going to give it a name. For example, we are going to create a section set for beams, columns individually. We can select any of the column, and the properties and the section information will be displayed here. So it's like the 4 into 13, but we know that it's like the depth is quite low. It is not going to pass, but we can just write here, and we'll just modify this in the design rules, or the design list will create later. You can just we are just going to create a section set for all of these columns right now here. And similarly, for the beams also, we are going to create a section set. We can just write a beam name, and we can select any of the beam. And for W10 into 26, we can just write it here. We can just display the shape from the property toolbar option at the left, and we are just going to give it a type beam. And for girders, we can just write it girder, and we can select any of the girder, and its property and its sections will be displayed here. W14 into 34, we can just write it here. And for that also, we are going to give it a name as beam. So right now you can see, if we select it by property, we can select the member, column member, beam member individually to give it a section set. So right now we are just going to create a column, and if we write the override previous selection, if we have selected previously any kind of the members, it will just overwrite it. Right now in the section shape, we can just going to give it a name column. And for all of the column, we have just created a section set. It has been displayed at red options, as you can see here. And similarly for the beams, we are going to use the select features. Right now, my columns has already been selected because we have not used the override features, but I'm going to click on this so that my columns, beams will overwrite my columns. And again, in the section set shape, we are going to select the section set and the beams. And similarly, you can see we have created the section set for column and beams. But right now, all the girders have been applied at the beam as well. For that, we can go on the other view, elevation view, and we can just select the top view. And there is some tools available if you want to select this particular beams, and if you just want to there is some options of the invert selections option that we are going to use for selecting the girders. First, we are going to select all of the beam members, and we just use the invert selection features available here, so that this only my girders will be selected instead of the beam. And again, we are going to give it a name girders that we have created. Right now, we can see we have already created the section set for column, beams, and girder. Now, in the design optimization part, we'll see the section set instead of all the individual member. We are also going to create some design list and the design rules. So for the beam, we are going to create a new beam, so like the white flange beam design list. For example, W4, I want to remove W4 up to the W6 section because it is going to be too small member. So I'm just going to remove that and we'll save as another one. By default, will be saved if we do so. Similarly, for the column, we are going to create a copy of this default, and we are just going to remove that W4 to the till W6 sections. So we have already created the design list, and in the member design rules, you can select like you can just dock the window and you can just give the design rule for your beams, columns, and the girders, like how much of the depth, minimum depth or the maximum depth, and the utilization ratio you want to set it. So for beam, columns, and the girders and the braces, I am going to create a member design rules. For example, for girders minimum depth of 14, I want to write. For example, if you are using the AISC, some manuals for the 14 depth, it has been written as 13.9. So if you write it just 14, the shapes will not be selected. So I've just written it here 13 to consider that shape as well. And you can just select the deflections values as well, and the shear and the utilization ratio, and the shear and the bending utilization ratio. Once you've done that for each of the beams, columns, and braces in the design list, which we have already created the copy white flange beam, we are going to use that for the beam and the column, white flange column for column and white flange beam that we have created by removing the W4 to the W6 sections. You can also see this information by clicking on the three dots. For the design rule which we have created right now, we are going to select it for column, beams, and the girders individually. So this way you can select your section set, design rule, and the design list. Then after we are going to solve this model and we'll see the code check result, and we'll apply the suggested design features. You can see the share check and the unit check values here. For the envelope reaction, I'm going to see like again my beams and the columns are largely going to fail. Now what I will do is I will just use the program suggested design features available here. And right now you can see we are not getting the individual member, but we are getting the section sets for columns, beams, and the girders that we have created. So it will just help me with the optimization. So I'll just use the program suggested to resolve the member. Right now you can see my braces have not passed, but all my columns and beams have been passed using this suggested design features. For the braces, we can just give it a different name, like for example WT. We can select, for example, if I don't want to use that design list, you can just change it as well. Right now, again, if I go on the selected design, and if I want to again solve with the suggested shape, that I don't want to use the suggested shape, that so right now we have suggested a WT shape, and it has already solved my model, and all of my members have been passed. By this way, you can just use the program suggested feature to solve your members, and you can just display your section sets and all the information which you want to use. So this is like the kind of the process how you can select, how you can create the section set, perform the design rules, set out the design list and design rules and code checkup, and the member design program suggested design feature that helps in the optimization. Also, you can check out the material takeoff values as well. So moving forward, like regarding the case studies, these have a detailed case studies on its website, like which includes several like the real world examples by showing, how the engineering companies uses the software for the different kind of the project. For example, that vary from large scale stadiums to the complex building geometries. Like this study also highlights like what challenges they face in the project, and how the engineers or designers have applied the RISA 3D to overcome the complex design challenge. Also, you will see how the flexibility of modeling and the connection to the Revit and the integration with the other tools and the speed of the design, say iterations, make it like a go solution for both the design and the optimization. You can check out all of this case study and explore more in depth through later at the risa.com/case studies. Moving on, here you will see about the customer RISA customer portal. Like you can access it at portal.risa.com, and it is basically a one-stop hub for everything that RISA provides. So basically, it's an online platform like where admin or users can manage the software license or can download the updates of the software, and also provide the support resources. Like it provide links to the tutorials or the documentation, the release note, or the verification examples, or any kind of the technical updates and the training materials. Uh, Also, the portal, can link directly into the cloud licensing, so you can log in and use the visa from anywhere on the any machine. And regarding the licensing time, we receive multiple queries regarding this. So I want to highlight Visa 3D license is a cloud-based subscription license. Like this doesn't come in perpetual anymore, and it provides flexible access. Means like your multiple users can be assigned under the single license through the Visa user portals here, but only the one active user can use it at a time, and anyone can have access, anyone who is added under that license can have access to the software from anywhere in the world. In the right hand side, like you can see the snips of my Visa portal, and in the overview tab, you will see all the Visa products you are using, and in the user drop down below, where admin can add and remove multiple users under the single license. So in the users tab, you can just add or remove your users. So regarding the latest versions upgrade, the latest version of the Visa 3D current is the version 23, which has been updated on September this year. So there have been many enhancement or the corrections made in the version 23 as compared to the last versions. Like it had added member design is for the AISC 360, which is the latest, like the 16th editions. Also, the ASCE code for the load combination generation has been added, and also the design response spectra and the wind load generations as per the ESC 722 has been added. Also, some enhancement like has been made in the integration with the RISA connections, in terms of like the load transfer, uh, or like in the reporting of the print options as well. Like you can find the release notes online and can have a look in more details about it. So to summarize, like what we have seen so far, like we have explored the RISA 3D interface and some of the modeling tools, and we discussed also the integration through the RISA links and the BIM utilities. Like in the software showcase part, like we have looked into the single angle behavior and understand like how this account for the torsion. We also have explored about the non-center line analysis by the rigid in and the analysis offset for the member design. And we have also understand and looked at the workflow for designing the hot roll steel sections, including how to create section set, design list, and design rules. and how to use the program suggested design for member optimization. Also, like I have shown about the latest version release and the software licensing type, and also information about the RISA portal and where to get the case study resources. And I hope that the sessions was helpful, and you can watch the recorded session later through our YouTube channel also, like we'll upload it there. So we'll display some of the poll questions here, and we can take few questions now. Please send your questions in the Q&A box meanwhile.
So thank you, Katie, for that detailed demonstration. Yes, we are running some polls. We are waiting for your responses. And as once you finish that, we move on to the questions. So please feel free to ask you if you have any questions. Go to the Q&A chat box that you can find on top. You can ask your question. Yeah. Okay. So we move on to some questions that we have. Some of them are in chat, some of them we get as frequently asked questions. So we'd like to, clear that. So first of the questions that we get is, can we model build up sections in RISA, and how does RISA handle composite beam and slab design?
Regarding the built-up sections, for example, like the I-beam with the two waves, or like these built-up sections basically would be created in the RISA sections, and this can later be imported into the RISA 3D. Like you can use the RISA sections to easily determine the section property as well. And the custom sections can also be imported into the RISA sections through the DXF, and that can be brought over to the RISA 3D to analyze later. And regarding your composite design in the RISA 3D, in the RISA floor is used for the analysis, code sec, and the member optimizations of the composite beams. In RISA floor, composite beams, you can define the hot roll I sections beam with a composite deck, attached to its top flange. The composite behavior is achieved by in the RISA floor. Like you can design the composite through the RISA floor in the RISA suite within the RISA environment. Yeah.
Thanks a lot for that, Katie. So next question that we get is, how does the TNX tower and RISA 3D integration work for lattice tower design?
The TNX tower, was once a part of the RISA, called the RISA tower. So the TNX tower can export a lattice tower file into the RISA 3D to take the advantage of the RISA more advanced 3D analysis tool, which may be a workflow that may be worth looking into. Is I have also seen in the import and the export file options within this presentation, like you can import the TNX tower file directly into the RISA 3D. And as per my knowledge, the typical workflow involves the modeling and loading the tower in the TNX tower and export it to the RISA 3D for detailed analysis, example, the model analysis, dynamic studies, and the secondary load effect like the P delta analysis, or to verify your complex bracing configurations. And once you analyzed it in the RISA 3D, you can just import the result back to the TNX tower for design checks as for the TIA. So as per my understanding, TNA towers remains the design platform while RISA 3D serves as an extended analysis platforms. Yeah.
Okay. Yeah. Thanks a lot for that. So, second last question that we mostly get is there an option to assign member stiffness modification factor to account for reduced stiffness of base timber? And how does LISA 3D handle material and sectional properties modification factors to simulate the effects of cracking?
To answer this question, so RISA 3D definitely allows you to modify the material properties through the metal property toolbar, which can indirectly account for reduced stiffness in the edge timber, like mentioned. So basically, you can adjust the modulus of elasticity, E modulus value for the wood material properties to reflect the reduced stiffness of the edge timber. This can be done by creating a duplicate of the custom material with an adjusted modulus of elasticity values. And to simulate the effect of cracking, you can modify the material property again and the sectional properties of the timber member. For example, you can reduce the cross-sectional area or adjust the moment of inertia to account for the loss of material due to the cracking. So this can also definitely be achieved through the member spreadsheet or by defining the custom sections set with the modified property within the RISA 3D.
Okay. Uh, Thank you for that, KT. So last question that we have is, can we define moving loads such as cranes load along a defined path on a structure in RISA 3D?
Yes, RISA 3D have a database like I have quickly shown within the model as well. Like you can add the moving load. So they do have a database for the moving load patterns. However, you can also add or can save the custom moving load as well. Can Basically this can be applied in any directions and they can be used to model the crane loading which are typically added in the 2 or 3 directions at the same locations. Like you can have multiple moving load in the each model. Like also you can animate your moving loads. And furthermore, like you can include a moving load in your load combination analysis as well, and maybe assigned to a single load combination. So yeah, this is a good topic actually to discuss. Like we can add this in our future webinars as well. Yeah.
So thanks a lot, KT. I think those are all the questions.
So thank you, Ashwin.
If you have
So I will hand over to you to give some information about our upcoming webinars and some other topics. Over to you.
sure, sure. Sure. Thanks a lot. So, if any of you would like to take a research 3D trial yourself, we encourage you to take 10-day free trial, which will be a full version and include all features and full support. You can download it directly from risa.com or you can simply write to us at solutions@thedatacero.in and we'll be more than happy to get you started. Coming to RISA customers, so RISA is trusted by engineering firms worldwide, from consultants to industrial design houses and infrastructure specialists. Its adoption continues to grow because of its speed, accuracy, and ease of transition from other platforms. And yeah, so here is some of our clients, what our clients say. So our clients have consistently highlighted how RISA helps them work faster and build trust in their designs and handles complex structures with confidence. Whether it's running a rapid what-if scenario and relying on accurate outputs or efficiently modeling integrate projects, RISA enables teams to save time and deliver stronger, code compliant results. Uh, Coming to support and learning, so at Acero, RISA, and RISA, we support is a priority to us. So we have dedicated channels for phone, email, and online help. About the licensing, so licensing will be a cloud-based licensing, as Keith has mentioned, and it will be it will offer flexibility for you. Right. Comprehensive learning resources like webinar courses, tutorials, manuals, and knowledge bases will are also available, and we can also share that with you. You can also explore RISA learning centers like training.risa.com or to get certified and stay updated. Coming to our upcoming webinars, at the end of November, we get a deep dive into Bluebeam. And in mid-December, we have a session on All Plan, which is a leading BIM design solution. So follow us on LinkedIn and subscribe our YouTube channel so you get updates for all the recordings. Uh, Here are our contact details so you can visit our office. We are based out of Noida Sector 57. And here is our contact number and email ID. You can call us or write to us, and we'll be more than happy to schedule a demo, provide you a custom code, or discuss any questions if you might have for any of our portfolio. So that's all for us. And thank you everyone for joining. It was a great session, and thank you, Preeti, for giving us a good, uh, insightful software demonstration. Thank you, everyone. Stay safe and see you next in our next webinar.
Thank you, everyone.